Alrighty, here we go. So one big thing is each time we finish one of these, we'll take a minute, we'll pause, and we'll just kind of reflect on the process. Because one of the things that I really want to establish with you and get kind of locked down with you is the best process for going through these. Because if you can really get this process down, then you'll be in good shape. So for starters, the process you're going to start with is you really want to try and do the thing that makes these unique is you get two sets of LOLs, one for one object, one for another object. In this case, you got these two rockets, right? And you really want to kind of do the first L at the same time, then the O at the same time, and then the final L at the same time. Okay, so that's kind of like, again, the process that you're going to want to do while you work on these. So I'll read this out loud, and then I'll let you, and then I'm going to ask you to do this first L, and give me a signal when you've tried it. So, two rockets are being tested by Elon Musk to supply the International Space Station. Both rockets have the same mass and aerodynamic qualities since they are both test rockets. Rocket A has the current model of engine, but Rocket B has new and improved engine, which delivers more force. If they both blast off over the same distance, answer the question, which rocket ends with the faster speed? Okay, so I'm gonna make it so I can see all of you. And I want you to try those first L's. Now, the big thing you're thinking about when you do these first, whenever you do any of this, is you want to think about, do they look identical? Do they look different? Now, they should have the same shape, meaning, like if one's got K, the other one's got K. If one's got UG, the other's got UG. But the big thing you're trying to think about is, does one have more? Does one have less? And that's where LT6 is unique and different. So give me a signal when you have tried both those first L's. Thank you, Annika. Thank you, Gabby. Thank you, Nathan and Noah. Thank you, Dorian and Jasmine and Sarah, Nolan, Charlize, Gavin. Okay, there we go. Plenty of us have attempted it, hopefully everyone. So let's see. Okay, I think this is actually super easy. We're on the ground, so right away we know that we've got no UG for both rockets. Give me a signal if you got that right, that there's no UG. And it is not blasted off yet. And so it's not moving, so there's no kinetic energy. So, hang on one second. I put that in the wrong L. So it's supposed to be here. There we go. All right, how many people got that right? Give me a quick signal if you got it right. Okay, now I want the O's are not hints. They're not empty, okay? And so I really want you to take a little time, think about it. There's gonna be some work here. Try both the O's at the same time, and what you're thinking about is, do they have the same amount of work? What is the work? Or does one have more? Does one have less? Give me a signal when you think you're done with the O's. Thank you, Nathan. When you're done with the O's, give me a signal. Thank you, Annika. Thank you, Jasmine, Reba, Gabby, Dorian, Sarah, Charlize, good. Uno. Okay, good. Here we go. So pay close attention. One thing that's important to think about when you're comparing any sort of energy, whether it's work, kinetic, UG, sometimes it's a good idea to write the equation out, right? And so we know we got work equals force times distance. And in this case, if you read through the problem, you see we're talking about the force of like the engine, right? And so it says rocket B has new and improved engine, which delivers more force. So that's bigger. And this is really important. Take a look at this because we need to know something about distance. It says they both blast off over the same distance. Okay. So that means that the distance is the same, but rocket B has more force. So that means rocket B has more work. So when I draw my arrows coming in like this, work of force engine and work of force engine, I need to show more going into B. So I'll go 1, 2, 3, 4 units of energy, and we'll just do like 2 going into A. How many people, and it doesn't matter if you did like 4 and 2 or whatever, how many people gave more to rocket B and less to rocket A? Give me a signal if you did that. Very nice, guys. All right, try the final L. See what you think there. Give me a signal when you have tried each of those. I appreciate that. I can tell most of you are actually trying this, not just listening to me. Thank you. I think you'll find that really helpful. Thanks, Emma, Nathan, Noah. When you've tried that final L, give me a signal. Thank you, Sela and Annika. Oh, yeah. Thank you. Evan, Nolan, Sarah, Gabby. Great. Okay. So I'm going to do it. Let's see what that final L looks like. Okay. Now this one's tricky. Okay. And go ahead and watch my screen. I know I'm just a little square there on your screen, but watch me if you can. So I happen to have this putty here. Imagine my hand is like the force of the engine, right? Watch what happens to the rocket when the engine stops. The rocket keeps going up. See, I stopped my hand right here, and yet this keeps going up. So one thing that I had a nice conversation with my other class about is that it still has some velocity when the engine stops running. And that's a little tricky, but if you think about it, it makes sense. It's like, just because the engine stops running doesn't mean it's still being launched up. It's still going to move upwards. It's just that it's not going to be speeding up anymore. So one thing we know is this, like I said, this part is definitely the trickiest part. Look, it says they both blast off over the same distance. So what that means is that, like, let's say the ground is right here. That means that they both blast off over that same distance. Well, guess what that means? That means they're at the same height. So this is a question I want to ask you. They both have the same UG because they have the same mass and the same height. How many people gave them the same UG, whether it was like 1, 2, 3, whatever? Give me a signal if you gave both rockets the same UG at that final L. Okay. Oh, okay. There we go. Third. Okay. But between a third and half of it. That's good. That was a tricky one. Okay. But we also, and this I'm not even going to ask about because this is particularly tricky. We also need to make sure that there's some kinetic energy. Like I said, just because the engine stops doesn't mean that the rocket ship stops. So we got to think about how much to give each one. Well, since there's only 2 units of energy over here, this is where I'm going to start. And so I need a little bit in both. I only have 2 units of energy, so I'll give 1 unit of energy UG and 1 to kinetic. So that means UG is the same, so I got to give 1 here. But in rocket B, 4 units of energy transferred in, so that means 3 must be in my kinetic. Okay. Again, I'm not going to pull if you got that one right because that was pretty tricky. But I do want to ask if you have any questions on this example, on this LOL. Okay. Now, so again, the big thing that I want us to focus on is kind of like the process, right? And so our process was we do both the initial L's, then both the O's, and then the final L's. Well, the next thing in our process that we need to do is really start getting into our explanation because that's our model. But we got to get into our explanation. And down here, what we're going to do is we're going to describe our model, LI, the initial L's, then the O's, then the final L's, okay? And so I'm going to do this first one for you. And then the next one, I'll ask you to try a little bit on your own. So what you're really doing is you're explaining why did you draw these 2 L's the way you did. And so in this case, they're both 0. So we're going to explain it. We're going to say both have a height of 0, so UG is 0. So both, or let's say are on the ground, so UG equals 0. And then we got to explain why the kinetics are 0. And it's that both are not moving. Both are not moving. So kinetic equals 0. Now, where it's a little more complicated is in the O. because now the next thing we're going to do is we're going to compare and describe. We're going to explain why did we make this O this way and this O that way. Okay, why did we put more energy going in to rocket B than rocket A? And so this is where you want to keep those equations in mind, right? Like this equation. And so we're going to describe why we did that. And we're going to say, because both engines ran for the same distance, but B had more force, B has more work. Okay, so we'll start with you, like B has more work. B has more work because it had more force over the same distance. Okay, and so and you really got to talk about both those things. You got to talk about the force and the distance, because together both those things go into work. All right, now let me give you a chance. Try and explain L final before I write it out. So your goal is to explain why did you make this L this way and that L that way. Give that a try. Give me a signal when you've attempted to explain L final. Okay, good. We're starting to get people. So like Nathan, thank you. When you finished explaining L final to the best of your abilities, give me a signal. Thank you, Pedro. Charlize and Annika and Sarah. There we go. Evan, Dorian, Julia, Reba. Okay, great. Ryan and Em. Okay, so one thing I'd like to start with showing you here is that you really want to start by talking about why you made UG the same. And so we know it says that the rockets have the same mass. And so we want to talk about that again. You really want to think about what the equation is, right? UG equals mgh. You don't have to talk about gravitational field because we're always going to assume we're on Earth, but you do want to talk about like mass and height. So you'd say both have the same UG because they have the same mass and the same height. So the same UG because same mass and same height. Now, let me do a couple check-ins with you guys. How many of you, give me a signal if you talked about UG first? Because that's how you wanted to do that. Okay. A few of us, not all of us. Give me a signal if you mentioned about the height when you were describing the UG, whether you did it first or second. How many people did? Okay, now for the tricky one, give me a signal if you mentioned the mass when you talked about UG. Did anybody mention mass? It's easy to forget that one, but you don't want to. You got to remember to do it, because if things have different masses, they can have different UGs, okay? Even if they're at the same height, right? Like if I've got a baseball and a bowling ball at the same height, the bowling ball's got more UG because it's got more mass. So you definitely got to touch on that. So anyway, part of the reason you want to talk about UG first is because then your last statement is going to be like, this means. So like this means, and when I say that, I mean all the stuff you've said, like all of the stuff up here and all the stuff in the middle and all the stuff at the end. All of that comes together to say this means that rocket B has more kinetic energy. This means rocket B has more kinetic energy. Okay, so because there's still one more part we got to do. Are there any questions at this point? So process, right? Process. Let's just recap. We start with both the initial L's, then both the O's, then both the final L's. And then we just really describe why we did what we did. We talk about the initial L's, the O's, the final L's, right? We just kind of like explain why we did things the way we did. But here's the crazy thing about these problems. It's a lot of thinking and a lot of writing, and you almost forget what the actual question is, right? The actual question is, which rocket ends with the faster speed, right? And we haven't answered that. And in order to do that, in order to answer that, we're going to really need to talk about kinetic energy at the end, which is why the last thing we said was about the kinetic energy at the end, right? And so now what you do is you take whatever that is at the end, and I recommend you make a little like comparison thing. So for A and B, and you're going to do like kinetic energy equals 1/2 mv squared. Kinetic energy equals 1/2 mv squared. Now, watch carefully because I'll have you try this next. So first you want to find anything that's the same. Now 1/2 is obviously the same. There's nothing to do there. But the masses are the same. It tells us that both rockets have the same mass. Now what we just proved is that rocket B has more kinetic energy. So I'm going to put an up arrow here and a down arrow there, right? B's got more, A's got less. And so when you do that, all of a sudden you know the answer about the velocity, right? If you have more kinetic energy here and these are the same, then velocity must be more here and velocity must be less there. So now we can answer rocket A has more speed, both rockets have the same speed, rocket B has more speed. Now we do have to explain this in words. I always recommend when you're going to explain in words, start with the thing that you circled that's the same. So that's mass in this case. So I say like, because mass is the same, but B has more kinetic energy, it must have more velocity. Here we go. And now we're done with the problem, right? So again, process, 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 right? We start by comparing the two L's, then the two O's, then the final L's. Then we just explain each thing one at a time. Why did we draw each of these things the way we did? Then we got to remind ourselves what the actual question is. And then you write a little like comparison chart here, and then you explain your comparison chart in words. All right. I do want to get on to the second one because we don't have a ton of time left and I want to get through it. So I want you right now to try these two L's for this one. Scenario number 2, a Matchbox car and a Matchbox truck are placed at the bottom of two different ramps. The Matchbox truck has more mass than the Matchbox car. The car and truck are both launched with the same kinetic energy. So give me a signal when you have tried these two L's, when you've compared these two L's, two initial L's. Thank you, Annika. When you finish drawing those two L's out to the best of your ability, give me a signal. Thank you, Nathan. Thank you, Nolan. Thank you, Noah, Pedro, Gabby, Ryan, Julia. Okay, here we go. Let's do it. So we see that they're moving at the bottom of the ramp, right? Moving at the bottom of the ramp. So if they're at the bottom of the ramp, there's no UG. They're at a height of 0. So I can make that 0. But they're moving, so they have kinetic energy. So, and which one has more? Well, neither. It tells us they're launched with the same kinetic energy. So I don't know. I'll give them both 3. You know, you could give them 2 or 1 or whatever, but or 4. Okay. Try the O's. See what you think goes in the O's. Is there any work being done? Now, one thing I'll tell you, It's not stated here, but we're supposed to assume that there's no friction. Give me a signal when you think you are done with the O's. I'll give you a hint. Should be really fast. Thank you, Gabby. Thank you, Nathan. Thank you, Sarah, Dorian, Uno, Charlize. So Emma, so why should it be fast? Should be fast because there's nothing there. The O's are blank. Thank you, Gavin. So how do we know they're blank? Well, they're blank because I just told you there's no force friction and there's nothing pushing the cars forward. So let me do a quick check-in because I think the last L is a little more tricky. Did anybody get both of those right? The first L and the O. Give me a signal if you got both those things right. Can I just get a quick check-in? Did anybody get both of those right? Okay, a handful of us, not a lot. Does anybody want to ask me any questions real quick, like on either of those two things? Okay, so then now I want you to draw and give me a signal once you've done this. What about the final L? So what do the energies look like when that truck and the car are at their maximum heights? Go and give me a signal once you've tried that. All right, there we go. Thank you, Annika. Thank you, Gavin, Julia, Sarah, Dorian, Nathan. Okay, good. So give me a signal if you realize this. At the max height, you hopefully remember that objects stop for a moment. So like this car goes up to its max height and it stops for a moment there, and the truck goes up and it stops for a moment there. So if it stops, there's no kinetic energy. Give me a signal if you remembered that. How many people remembered that? Okay, about half, about half. So, well, then that's pretty easy then, because that means that if we've got, for me, 3 units of kinetic and nothing else, and there's no kinetic here, then we must have 3 units of UG, right? And so that's true for both of them. All right. Now, let's try the explanations. So I want to give you a chance, L initial, O, L final. Try and just write out the L initial. See if you can explain why did we draw this L like this and this L like that. Try that. Give me a signal when you've tried the L initial. Thank you, Annika. Thank you, Nolan. Thank you, Charlize and Sarah. Okay, in the interest of time, I'm going to jump in and do this. You can let me know how you did. So the easiest thing is start with UG. You don't have to on this one, but it's the easiest thing because of height 0. So since both are at the ground, UG is 0. And we're told they've got the same kinetic energy. So it's like a given, and that's okay. Given both have the same kinetic energy. Now let me show you what you say for an O when it's blank like these. And basically all you have to say is there's no outside force, right? So then you say like, because there's no outside force, like friction or push or anything like that, because there's no outside force, there's no work. So that's why those are blank. Now, again, in the interest of time, I will wrap this up just so we can get out of here on time. And so on the final one, what we're going to say is we'll start with the kinetic energy. We'll say because both stop at the max height, the kinetic is equal to 0. And then we can say this means, right? Like I said, you always want to end by saying this means. So this means they have the same UG, okay? And so now we got to remind ourselves what's the real question we're answering. And the real question is which car will reach a higher height on the ramp? So to answer that, well, we're going to talk about UG, right? UG talks about height, and we'll talk about it at the end. So we'll make our little chart with UG. We say for the car, UG equals MGH. And for the truck, UG equals MGH. So now we got to compare them. Well, you don't have to talk about this, but you do know that the gravitational field is the same because they're both on Earth. We're told the truck has more mass and the car has less mass. And we just proved they have the same UG. So now we know the answer to the height. And it means that the truck must go to a lower height and the car must go to a higher height. For example, let's just think about values. Let's say they both had a UG of 10 joules, right? And let's say gravity was 1. And if the truck had more mass, let's say it had a mass of 5, then it would only go to a height of 2 meters, right? On the other hand, the car, say it's got 10 UG and gravity's 1, but it had a mass of 2, that would mean it would go to a height of 5, right? So that explains it. Now we need to write this little thing in words. And I always recommend you start with the thing that's the same. In that case, it's gravity and UG. So you'd say since UG and gravity are the same, but the car has less mass, it will go to a higher height. And there we go. I know our time is